Okay, here we go. Number one, find the slope. So when you have a graph, you should draw a triangle for the slope. It's literally called a slope triangle. Count the boxes. 1, 1, 2, 3, 4, 5. Okay, and then the slope is rise over run, so 1 over 5. And then notice that it's going downhill, so that makes it negative 1 over 5. Okay, now this guy is horizontal, so the slope is 0. Horizontal lines have the slope of 0. Now, just because we're here for a moment, we're dealing with the horizontal line. I want to ask you, what is the equation though? It didn't ask us for the equation, but we need to practice it. What is the equation when a line is horizontal? Yeah, it would be -2 actually, I think. Okay, so this spot right here is -2. So the equation is y equals -2. That was extra. We didn't have to do that. I just really want to hammer in the equation of horizontal and vertical because they're kind of weird. Okay. Number 3, find the slope of the line through each pair of points. We need a formula for that. M equals y2 minus y1 over x2 minus x1. X1, y1, x2, y2. M equals y2 minus y1 over x2 minus x1. Just really -17 over 34. -17 over -34, which is 1/2. I don't know if any of you guys out there are like fully aware that 17 times 2 is 34. Takes me a minute. Okay, number 4, M equals y2 minus y1. Really careful with the double negative there, y2 minus y1 over x2 minus x1. So 2 minuses next to each other is plus, so this is 23 over 0. You cannot divide by 0, so this is undefined. What kind of line has an undefined slope? Vertical. Okay, so we're going to draw a little baby picture. And how do I do the equation for a vertical line? Yep, x equals. And so you go back to the problem points and you're like, oh yeah, look at that. The x's are the same. So my equation is x equals 9. Okay. That is the topic of slope. Do you guys have any questions about slope? before I move on to graphing lines, where we use slope, but it's not the full thing. Okay, scroll down to number 5 and 6. Sketch the graph of each line. Okay, so in this one, the slope is -4. And the y-intercept is 2. Slope -4, y-intercept 2. Graph 2 on the y, because it's the y-intercept. Okay, now if the slope is -4, what I like to do is I like to put it over 1 because anything divided by 1 is itself. And then it's negative, so I'm going to go down and right. So since the slope is negative, I'm going to go down and right. So down 4, right 1. Make sure that you put all the possible dots on the paper that you can. So go forward and backtrack. Okay. Slope is -3/5. Y-intercept is 1. Y-intercept of 1. Slope of negative. So I'm going to go down 3, right 5. Anything from 5 or 6? We good? Okay, now go down to 7. 7 is a topic that everyone forgets. Everybody forgets the thing, so it's really good that we have one on here for us to go over. This would be a great problem for your note card. Find the x and y intercepts, then sketch the graph. Okay, so for the x-intercept, y is 0. And for the y-intercept, x is 0. Okay, so you're going to do 2 separate problems. One of them where you put 0 in the y spot, and one of them where you put 0 in the x spot. So 3x plus 2 times 0 equals -6. So I put 0 in the y spot. Now this one, I'm going to put 0 in the x spot. Zero times 2 is just 0, so that just goes away. So I have 3x equals -6. So this is the point -2, 0, which is right here. This is the point 0, -3, which is right here. Bless you. And then sketch line. Okay, now, spoiler alert for the test. There's a test question where it asks you to find the x and y intercepts for A, graph them and connect them to make a line for B. And then for C, it says, now look back at the graph and tell me what the equation is in slope intercept form. Tell me what the equation is in y equals mx plus b. Okay, so what we have to do you guys want to do that together on this while we're here? Okay, so what you do is you make a slope triangle. Look at Mrs. Talbot putting two topics together. Oh man. Make a slope triangle and count the boxes. Notice it's going downhill, so m is -3/2. B is, we already have that. That's -3. That's the y-intercept right there. So y equals -3/2x minus 3. All right, flip to number 8 when you're ready. Okay, write the slope-intercept form of the equation of the line. Slope-intercept form just means y equals mx plus b of the equation of the line to the given point with the given slope. Okay, so m equals x equals y equals. M is the slope. X is the x of the coordinate. Y is the y of the coordinate. Y equals mx plus b. 4 equals -2 times -3 plus b. Yes, sir. 4 equals 6 plus b. -6 -2 equals b. And no matter what I do, how many times I say it, somebody is going to leave their test just like this without writing the final answer. It asked for the equation, so the final answer is y equals -2x minus 2. Somebody's going to put b equals and then think that they're done. Try not to let that be you. Okay, number 9. Write the slope intercept form. That just means y equals mx plus b form of the equation of a line through the given points. Okay, so this one we have to do more work because we don't have the slope, so we have to find it. Y2 minus Y1. Be really careful. Over X2 minus X1. Did I screw up? Because it happens sometimes. Okay, so I'm going to change this. I'm going to act, because this is notes, I'm going to change these minus negative to pluses. So notice I got negative 4/8. I moved the negative in the front and then reduced. Okay, which point do you guys like better? They're both not great. Probably the second one, because it's only got one negative. What's negative 1/2 times 4? -2, perfect. Should I walk away? Should I drop the pen? Should I turn it in? No. Okay. Now, your two favorite topics of the chapter, unit rate and dimensional analysis. Oh, how you love them. I just know already your extreme love for them. Okay, so last two, and probably the hardest two. So let's get ourselves back here. Okay, so draw a graph for the following situation to calculate John's unit rate for each piece of his journey. Be sure to label your axes. Okay, so first we need to label our axes. It says that he walked 4 miles to school at 2 miles per hour. Okay, so you know what I'm gonna do? This is gonna seem strange. I'm gonna put this over here. And then I'm gonna do the work for number 11 down here. Because dimensional analysis, you kind of need like, to go horizontally. So I'm gonna put the first piece here is 2 miles per 1 hour. Okay, 2 miles per 1 hour. Okay, so let's go really slow. Slope is rise over run, right? Slope is rise over run. Okay, so if I have miles per hour, where do those go on the axes? If this is the rise and this is the run, or this is change in y over change in x, what units go on the Y? Miles, yeah. Per hour. So remember, okay. So now it says he left home and walked 4 miles to school at 2 miles per hour. Okay, so we're just going to start. He left home 0 miles from home. He's at home right now, and he's going to go 2 miles per 1 hour. 2 miles per 1 hour until he gets 4 miles away. Sure. I think it's a terrible time to, but it's up to you. Okay, so he walked 2 miles in 1 hour, and then he walked 2 miles in 1 hour, and now he's 4 miles away. Okay, so what is the unit rate here? 2 miles per hour. You don't have to do anything to it because there's already one on the bottom. Okay, he stayed there for 2 hours. Okay, so hour 3 to hour 4, he stayed there, which means this piece is flat. What is the slope if the piece is flat? Yeah. You can also think of it as like 0 speed. So that's piece 2. If you want to label them, this is piece 1, this is piece 2. Okay, and then he walked home at 3 miles per 2 hours. So 3 miles per 2 hours. So I just sort of stepped it like this. I went 1, 2, 3 miles per 2 hours. And I went backwards because it says he's walking home. So he's going back toward his house. Okay, and this is really important that you have the negative here because you need to know that since he's walking back, the slope is negative. Then you go on the calculator and do -3 divided by 2. And get negative 1.5 miles per hour. Okay, so remember, unit rate, the words unit rate means slope with units. Again, unit rate, the words unit rate means slope with units. So you're just finding the slopes, putting the units. Okay, last one, your favorite. Oh, look, I embedded scientific notation into dimensional analysis. Aren't I just, anyway. Chicago uses 1.2 times 10 to the 9 gallons of water a day. That's a lot. Just saying. Okay, so we're going to write 1.2 times 10 to the 9 gallons for 1 day. How many gallons per second must be pumped from the lake every second to supply the city? Okay, so it wants gallons per second. Do you see how I already have gallons? I don't need to mess with that. I just need to mess with the days. Okay, we need to get days to seconds. Let's do something easy. How many hours are in a day? 24. Okay, so there's 24 hours in a day. Does the day go on the top or the bottom? Top. What's the units right now if I were to leave this? Gallons per hour. Okay, now I'm going to go hours to minutes. How many minutes are in an hour? 60. Okay, hours on the top or the bottom? Top. What units am I in right now? Gallons per minute. Is that what it asked for? No, it wants gallons per second. How many seconds are in a minute? 60. Minutes on the top or bottom? Okay, now how do I do them? Like, what am I going to type in the calculator here? 1.2 times 10 to the 9. What do I do for this? Divided by 24. Uh-huh. 60. What do I do with that? Divide 60. Divide 60. 1.2 times 10 to the 9. Divided by 24. Divided by 60. Divided by 60. 13,300, no, 888.9 gallons per second. Ooh, goes down here. Okay, now just for fun, I'd like you to think about the amount of water it would take to flow 13,888 gallons per second. So one second, just there, just now. Almost 14,000 gallons of water. But I don't know if any of you have been to Chicago. It's huge. Chicago's really big. Super cool city. Great place to go Christmas shopping. Just saying. Okay. So let's look at the stamp sheet side, please, and thank you. These are the three things that I need to stamp. Everyone gets a stamp for the puzzle because everyone finished it. So you don't have to show me anything for that. We did it on whiteboards. Did I stamp you already? No, okay. I know everyone that was here gets a stamp. And you, if you weren't here, you have to get a stamp too because I'm not getting the puzzle back out. Homework was 113 to 117, and then we just did the review notes. So if you could have your packet open to the review notes, and have your notebook open to 113 to 117, please. And then after I stamp you, work on 118 to 123. Oh, wait. Hold on. Hold everything. Holding. Are you holding? We need to read this. Okay, we need to read this, but why is it behaving so poorly? Okay. Our next test is on Thursday, October 16th. That's a week from Thursday, it's not 2 days from now, it's a week and 2 days from now. You can use note card and calculator. Okay, here's your topics. Function machines forward and backward. Stating and justifying whether or not something is a function, and domain and range. That'll be all one problem. Exponent. Finding the slope from 2 points. Graphing lines. Writing equations from a graph, a table, and 2 points. You know what I mean by that? Like looking at a graph, getting the slope from the triangle and B, or getting the growth from the table, finding the zero, or 2 points and do them, algebra part. Slope is unit rate. That's the one we just did with John walking toward his house, whatever. X and Y intercepts, we just did that. Dimensional analysis, your favorite. And then using angle relationships to solve equations. Okay, so that is, like a 8th grade thing. We spent some time on it in chapter 1. You guys have a green graphic organizer with all of the angle relationships. Hopefully you didn't lose it. If you did lose it, I have mine if you would like to see it to work on your note card or equation. But you guys know what I'm talking about? The angle thing, like vertical, supplementary, alternate interior, all that. Okay. Any questions about the topics? All right, now I'm done. I will come stamp and work on your homework, please.